get a full screen here. So I thought I'd tackle some of the problems that you looked at today and try to talk a little bit about why there was difficulty. And one major theme that caused problems was just really stems from not enough practice at the Algebra 1 level, writing addition and subtraction in terms of multiplication. So this was a simplification problem, and the difficulty came from not being able to rewrite it in the following way. The first rule of writing products is take out what's common. Sine x times, I'll put it in brackets, sine squared x plus cosine squared x. It was a one-step problem, seeing the common factor, and not seeing a common factor really stems from not doing hours and hours of factoring a couple of years ago. Okay, I'm sure folks know what sine squared x plus cosine squared x is, so that statement simplified to be sine x. So that caused problems. It also caused problems with, although I don't think it was the fundamental problem, but some folks, well, let's talk about simplifying a fraction. If you have 6/9, you're going to call it 2/3. Why are you going to call it 2/3? Because there's a common factor. And what happens with that common factor, it divides out of the problem. All right. So if you're going to simplify a fraction, you have to have a common factor. Well, this is what we were studying. We were studying the sine, the cosine, and 1. And we've been studying sine squared and cosine squared and 1. And been saying quite often, 1 minus cosine squared is sine squared. So this becomes 1 minus cosine squared x over sine over 1 plus cosine x. And now we're at the same place. A few people got here and didn't know what to do with it. Once again, not enough hours of practice factoring 2 years ago. 1 minus cosine squared x is 1 plus cosine x times 1 minus cosine x, just a difference of 2 squares, over 1 plus cosine x. And hopefully, bumpity, bumpity, you can now see what that simplified to. This skill also caused trouble with solving 2 sine squared x plus sine x minus 1 equals 0. I can't tell you how many people put a 1 over here. Fundamentally wrong from studying 2 years ago. This is no different than factoring 2x squared plus x minus 1. It's no different. That's a trinomial. That's a trinomial. So down here, 2 sine x, first parentheses, sine x in the second. That times that is that. There's only one way to get the number 1, 1 and 1. 1 times 2 is 2, so that gets the plus, that gets the minus. It's still an equation. So therefore, the sine function could equal a half. And if you've gotten there, I'll put my money on you. 5 or 6, 5 pi over 6, I'm sure most folks in the room would have been able to give me that, right? Half, there's 0, there's 1, there and there, yes. And sine x could equal -1. I feel pretty confident that people can tell me that -1 happens at 3 pi over 2. If all I'd given was this in factored form, you learned the trig, we would have been in good shape. Okay, but if you're going to go up the ladder in this discipline, you got to have factoring skills. So you might, if you're going to be taking calc next year, do some work at that Algebra 1 level, go back to it and really practice some factoring. It's going to really help you next year. And if you continue to make those types of mistakes in the next level, it's not going to go well. All right, so let's see, is there another one that factoring came into play? Let's see. Well, let's just talk about Algebra 1 skills. x minus 2 equals 4, 5 minus x. People got really good at 3x minus 6 equals 2 squared, so 10 minus 2x. I saw that a lot. I also saw mistakes a lot after this line of work. And I think it stems from the scales of justice approach to solving equations, which I don't think serves you well. I think you're more inclined to make careless mistakes. Think solving 90% of equations with inverse operations. All right, I'm subtracting 2x on this side. I'm adding 2x to that side. I'm subtracting 6 on this side. Right? I know everybody knows how to do that as I say it, but I'm not seeing it done easily and quickly on your exams. I'm seeing too many careless errors from here to here. All right, and that's on you. You can't afford to make those types of mistakes. Okay, what's next? Same type of mistake here. Talk about algebra 1. This is an algebra 1 problem. Still trying to close those gaps. All right, so it's not factorable. So completing the square, most of you tried to do that. So x squared minus 6x is equal to negative 11. All right, so where do we go from there? We practiced rewriting that. That's x minus 3 squared minus 9 equals negative 11. I saw a lot of people get there and then mistakes. It shouldn't be. Subtracting 9, let's see, subtracting 9 becomes addition of 9. So x minus 3 squared, if I add 9 to that, I get negative 2. And so therefore, x equals positive 3 plus or minus, still not seeing that all the time, square root of 2i. All right. So just the simple addition and subtraction mistakes, a lot of them on the test. All right, so gotta tighten that up, as they say. Okay, what's another one over here that caused some trouble? Secant x plus tangent x. Yeah. Oh, that's another factoring situation. So you're trying to prove this is sine x plus tan x over, what was it, 1 plus secant x. Trying to prove that was equal to the sine function. Didn't see too many lines. A few people did remember to do that. So what do we have? We've got some fraction work. We've got sine x. Make sure you can see this. Yes, you can. Plus sine x over cosine x. Big fraction bar divided by 1 plus 1 over cosine x. And so both of these fit the form of a plus b over c. And that becomes ac plus b over c. We practice that a lot. Bingo, bango, bongo. I wouldn't have to write that. I can see the a times c, the 1 times b and the c. All right, so what's this thing become? This thing becomes sine x times cosine x plus sine x. Both of those terms are being divided by cosine x. And if you divide cosine into both, you can see it come back to that numerator, divided by another bingo, bango, bongo. Cosine x plus 1 over cosine x. All right, I'm probably going to keep writing here and then I'll shift over here and write down some more. All right, so what do we have? We've got division by cosine x in both places. We said you can cancel that. Why can you cancel that? Because you have sine x, cosine x over cosine x multiplied by the reciprocal, which is cosine x over cosine x plus 1. Okay, so hopefully we can see that now that cancels. I'll shift over here to sine x, cosine x plus cosine x over cosine x plus 1. Now already on this video, you've had some practice. You've had some practice with where people got stuck. People got stuck there. How do you get unstuck? It's a fraction. How do you reduce fractions? Common factors. Oh yeah, there's a common factor. It's cosine x. Did I misstate something here? Sine x, did I copy it? I copied it wrong, sorry. That's sine x, copied it wrong. Okay, so what's the common factor? Sine x. And yeah, so because I miscopied, I should have given you a little more time then to look at that. So sine x times, I'll put it in brackets, cosine x plus 1. And that's being divided by cosine x plus 1. I think we can say, oh, yes, that's the sine function. All right, so that one skill, that one factoring skill, take out what's common, actually affected 4, maybe 5 problems in this test. And that's going to continue to be the case when you do problems next year. So you've got to learn that skill. Okay, what else do we have? We have, I think we solved problems like 2 sine squared x minus 1 equals 0 in class and on tests quite often. And that's equal to sine squared x equals 1/2. And that's the one that I put on your test. We also did 2 cosine squared x minus 1 on worksheets and on tests. I decided to save you a couple of lines of work by just writing it here. I'm not sure that might have hurt. Might have been looking more familiar to you. That might have been in your muscle memory, but it sure didn't show up here. So what's the first step? Plus or minus the square root of 1/2. We talked about the square root of 1/2 being very close to 0.7. We had these drawings. 1/2. 1/2 adding up to 1. Oh yeah, the 45-45 triangles were under consideration. Very first day of the term, or second day of the term, we looked at that being the square root of 1 over the square root of 2, multiplying by square root of 2, square root of 2, gets me root 2 over 2. All right, we talked about it. We did that out. We even squared 0.71. We squared 0.7 as another way to look at this. Oh yeah, 0.49 and 0.49. Oh yeah, that is pretty close to 1, isn't it? Oh yeah, and that putting the 1 there even gets it closer. And we said that it's really closer to 0.706. All right, so those are the discussions that were happening, and somewhere along the way, this didn't happen, and converting that to that didn't happen. So maybe it was too tough a question. I don't know. All right, what else is over here? Straightforward bingo, bango, bongo problem, and I think we're done. Yes. So this was a straightforward bingo, bango, bongo. And in class, I know for a fact, we talked one day about what's the first step for doing a problem like that. Oh yes, open parentheses. And then what do? You fill in the parentheses. Bingo, 5x minus 20, 5 times x minus 4. Minus, bingo, 3 times x minus 2, 3x minus 6. Bongo, x minus 2 times x minus 4. Okay, so what does that become? Kind of did that rather largely, so I'll just put a quick answer over here. 5x minus 3x, 2x, minus 20, minus a minus 6, minus 14, over, you could leave it like that because this could have been factored, 2x minus 7, that's fine, but none of those factors cancel. So this is probably 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. That's an easier way of writing it, one less stroke of the pen. Here, you probably textbook would ask you to write x squared minus 6x plus 8. And that's this answer, okay? And this continued to be a problem. So hopefully, you know, the ultimate goal of the class is to learn how to do things a little better. And even though it's, you know, we're not testing anymore and class is over, it's still important to look at because you got to have that skill going forward. So hopefully you're still taking a moment to try to improve your abilities in mathematics. All right, so there's some of the ones that cause the most problems. I will upload, maybe I'll do some more, but I still got a couple of tasks to complete here. So that's it for now.